Okay. So for this one, what we're going to do is just basically fill in our little graphic organizer, write it into your notebooks, and then a few examples just using those negative powers and everything else. So we talked about basically if I take my x and make it a negative, what's going to happen is now it's going to basically flip it, and I'm going to put my x, and then that a is now going to be positive because where it was, if I put it over one like a whole number because I got to make into a fraction, it's going to take all of this and flip it to the bottom. Now, if I don't have anything left up here, so like basically once I move all this down, there's nothing going to be on top. So you always have to put that 1. So let's go ahead and practice on these two here. So I have a negative 5x to the negative 2. So we're saying the exponents are negative. So this negative 2 right here. So in other words, what we're focusing on is just moving this part, whatever it's attached to. So what's going to happen is I'm going to take all of this x and this negative 2, and I'm going to flip it. Negative 5 is still there. Even though it has a negative in front, that's not a negative exponent. So I'm taking all my x's, and I'm basically moving it to the denominator to the bottom of my fraction. And that's pretty much the negative exponent rule. Now here, if you guys were to do your quotient rule like what we did yesterday, what would happen is I would simplify these two first. So 4 and 8, I can simplify 2, or I can simplify 4 out of each one. So I'll have a 1 over 2, or half. And then what would happen is if I do the rule for quotient rule, and if I do the 2 minus 5, what's going to happen is going to give me a negative value. Now you can do it the other way that we showed you guys and do it expanding, where basically how many k's would I have here? I'd have 1 and 2. How many k's would I have down here? I would have 5 of them. And then I will go ahead and just cancel out the ones I have. So these two, and these two. And if you notice, however many k's I had left, did too many. Try that again. 1, 2, 3. So how many k's I had left would basically be what I would have in my answer. And notice where they're at. Are they on the top or are they on the bottom? So our case, I have only the 1 up on top, the 2 here, and then I have 3k, so k to the third. Look back at your pattern. The other rule, and it's a pretty simple rule, is I want you guys to take a look at when we had 2 equal to the 0 power and 5 equal to 0 power. What were the values of those two numbers? Yeah, if you have 1, that's it. So anything to the 0 power is always going to equal 1. So in our case, whatever that 0 is attached to, it doesn't make the whole thing 1. It's just whatever it's attached to will turn it into a 1. So in other words, take a look at this one. X, I have 7x to the 0 power. So the 0 is only connected to this x, not the 7. So what's going to happen is this term here is just going to turn to 1. So now I have a 7 times 1, and then I go ahead and simplify, and I would just get 7 here. Okay, so kind of seeing that little rule in action. So product rule, or power rule. So if, in other words, if I take these two, I'm going to repeat this here. I'm going to have W 1, 2, 3, 4 twice. 1, 2, 3, 4. And then I have my 8 W's down here. 1, 2, 3, 4, 5, 6, 7, 8. And now let's go ahead and cancel. These two cancel each other. These two cancel. These two, these two, these two, these two, these two, and these two. So if you notice, every single one of them canceled out. And what happens is you can't just leave it as a 0. So if I have nothing left, there's going to be 1 up here. If I have nothing left down here, there's going to be 1 up here. So 1 divided by 1 would equal 1. And that's kind of what the 0 exponent rule is saying for our example.